Okay, today we're going to talk about section 9.4, adding and subtracting rational expressions. Now we're going to use some of the techniques that we talked about with simplifying rational expressions, except for now we're going to just combine two or more of them together, mainly two. Now, the big rule that you want to follow, just like with any fractions, is that you need common denominators. So as I look at these two that I have up here first, I notice that I don't have common denominators. So to get common denominators, what I'm going to do is first I'm going to look to see what kind of factors I can create using these. Well, I notice on the first one I could factor out a 2. On the second one I could factor out a 4. And you can see that these two denominators are a lot more uncommon than what you might think. They both have x minus 4s. So to get a common denominator, well, since they both have x minus 4s, this one has a 2 as a factor, this one has a 4. What I can do is I can multiply this left fraction by 2 over 2. And that would become 2 times 2, 4, so that will get us common denominators. So if I do that, let's see, up on top, I am going to simply distribute. So I'll get 2x plus 8. On the bottom, 2 times 2 is 4. Now I'm just going to leave it factored for a moment. And then over here, this is staying the same, obviously. Now this is a pretty important little hint right here, tip to you, is that leave your denominators factored for now, because eventually we might have to do some canceling, and that would be helpful to have them factored. So let's simplify the tops. Since the denominators are at the bottom, that means I can simplify. Now I have a minus sign here, so I'm going to distribute that to both of these, so it becomes negative and negative. And now if I simplify, 2x plus a negative x is x, and 8 plus a negative 12 is minus 4. Then the last step is to look to see if you can do any more canceling, and you notice here I can. We have this x minus 4 and this x minus 4, so I can cancel. Remember, when I do that, I have a 1 left over up on top, and 1/4. So that reduces down to 1/4. Okay, simple as that. Whoops, sorry, didn't know I was off the page. Okay, let's move on down to the next one. Next one's a little similar, but actually a little bit easier. So let's take a look here at my denominators again. You can do a couple things here. First, one is if you wanted to, you could reduce these. You notice that top and bottom I could reduce. So I could actually cancel those out. And then over here I have 1y, and that'll go away. So I'm left with negative 7y over 3 plus 4y over 2. And actually I could have reduced those also. I didn't even notice that right away. But let's just say we don't, since we didn't right away. So what kind of common denominator do we need? Well, between 3 and 2 it would be 6. So I'm just going to multiply this by 2 over 2. And this by 3 over 3. So when I do that, I get negative 14y over 6 plus 8y, whoops, sorry, 12y over 6. Same denominators, so I can combine. Looks like those are like terms. I can get negative 2y over 6. And I can reduce a little bit more. Since I didn't reduce up here, I'm going to catch up here by reducing here. 2 goes into this once, into that 3 times, and I'm left with negative y over 3, just like that. So again, hopefully that makes sense. You know, we're just trying to get some common denominators. Now you can't always reduce like we did right there, but if you can, that's always a good idea. So let's try another one. Now this might be helpful. This is an opportunity here where it might be helpful for you to just hit pause and give it a shot on your own. Okay, so look at this one. Now the difference on this one is that as I look at these bottoms, I notice I can't factor anything out. So how do I get common denominators? Well, sometimes, unfortunately, the easiest way to get a common denominator is you simply have to multiply by what the other denominator is. So for instance, this over here, I'm going to have to multiply by x plus 1 over x plus 1. And over here, I'm going to have to multiply by x minus 2 over x minus 2. Sorry, that's crammed in there. So when I simplify, I'm going to distribute. So I'm going to get 4x minus 8 plus, distribute this, 3x plus 3. Now since they're the same denominator, I'm just going to combine it as one fraction. And again, I'm going to leave it factored for now, just in case I can do some canceling later on. Combine some like terms again. So 4x and 3x is 7x minus 5. And let's see, anything else here? Well, it looks like there's nothing else, so I could actually multiply these back together, but to simplify our lives, I'm going to tell you it's okay to leave it factored. Now again, just like I told you, I think in the last set of notes, to be truly simplified, you should actually multiply that out. You should FOIL that out. But I know that you know how to do that, so we're going to try and make your lives a little bit easier. And I'm just going to tell you that's okay to leave it as is. Okay? All right, let's try another one here. Let's go on down. All right, so again, I look at this one and I notice that not common denominators. So the best thing to do again is to, if possible, factor. Well, I can factor both of these. This one is x plus 1 times x plus 1. And this one over here is x plus 1 times x minus 1. Now, what do I want to do? Well, I notice here that this has two x plus 1s. This one has one of them. But this one also has an x minus 1. So I can do a couple things here. One is I could multiply this by x minus 1 and x minus 1 on top and bottom, and then this by an x plus 1, x plus 1. But what you could also do is you could be smart about stuff, and I noticed at the top here I could factor out a 3. And I noticed that these would cancel. And over here you notice that these cancel. So what am I left with? Well, I'm left with a 3 and an x plus 1 plus a 1. Since that whole thing canceled, there's a 1 over x minus 1. So that cleans it up quite a bit. And although these look like they're real close, they are not. We still need to multiply this by an x plus 1 over x plus 1. But because I reduced over here, it's going to make it just a little bit easier. And over here, I'm going to multiply by an x minus 1 and an x minus 1. These technically should have parentheses like that. And so when I do that, if I distribute 3x minus 3, here I'm just going to be left with an x plus 1. And on the bottom, I have that x minus 1 times x plus 1. Simplify a little bit more. Here I'm going to get a 4x minus 2 over this x minus 1, x plus 1. And again, once I get down to this point, I ask myself, can I reduce or simplify some more? Well, I could factor out a 2 right here, but that's not going to help us because we'll end up having a 2x minus 1 in the as the binomial, and it won't reduce. So I'm going to leave it just like that. Once again, I've said it many times, and I'll say it again. To be truly reduced or simplified, you should multiply that out, but for at least our class, we're going to say it's okay to leave it as is. Okay, almost done. We got one last one we're going to talk about. This is kind of an oddball one, but this does pop up quite a few places. You notice we got a bunch of fractions inside a fraction. We have 1 over a plus 1 over b over 1 over a minus 1 over b. So what we want to do on this one is we want to try and reduce it. Well, if you notice, if you just kind of look at the top here for a second, what's the common denominator between a and b? What would be ab? On the bottom here, what's the common denominator between A and B? Well, again, it would be AB. So I'm going to show you a little trick here that'll make life a little easier. And what if I multiplied the top, the whole thing, by AB, and the bottom by AB? Okay, now that's okay, because remember that's 1 right there. Now when I do that, I'm going to have to distribute this to both these things right here. So if I multiply AB times 1 over A, now this, I'm going to write this out kind of lengthy. You can skip this step. I'm going to get this plus AB over B. On the bottom, if I do the same thing, okay, I'm going to get AB over A minus AB over B. Now that step's, you don't have to do that step, but I just wanted to show you that. And look what happens. Reduces, and that reduces. So I get B plus A. Here, reduces, reduces, I get B minus A. Well, now that I got to that point, is there anything else I can do? Can I cancel out the B's or the A's? No, because they're both terms. Are these opposites of each other where they would reduce to -1? No. If this said negative B right here minus A, then they'd be opposites. So you're actually done at this point. So a problem that looked fairly complicated to begin with, not that complex. So that's adding and subtracting rational expressions. Takes a little bit of effort, no doubt. But just like with fractions, when you learned way back when, whatever grade that was in elementary school, you still have to get common denominators. But the only thing on this time is that usually you have to factor first to really see what that common denominator is. So as always, if you have any questions, make note of it, and make sure you come to class tomorrow with those questions ready to go. All right, thank you.